Welcome to my series 100 Scientists Who Influenced the World, where I've taken a diverse mix of people and broken them down into 10 different categories. There are some famous scientists as well as some lesser known ones, but all of these people have influenced the world. For centuries, humans have stared up at the stars and wondered about our place in the cosmos, leading people to study what is out there and make some incredible discoveries which have changed our understanding about the universe. But who are some of these amazing astronomers? Nicolaus Copernicus. Nicolaus Copernicus was born in 1473 in Poland, and he was a theologian, mathematician and an astronomer. While working in an administrative position within a church, he pursued his passion for astronomy and, through many calculations, worked out a new model to explain the movement of the objects within our solar system. This is known as a heliocentric model, meaning the Sun is at the centre with everything else revolving round about it. Though we now know this to be true, this went against a majorly held religious belief at the time that the Earth was at the centre with everything moving around the Earth. So although he had already completed his book, The Revolutions of the Celestial Spheres, he did not publish it until a few months before his death. The work of Copernicus revolutionised astronomy and led to further developments by the famous astronomer Galileo Galilei, among others. Tycho Brahe. Tycho Brahe was born in 1546 in Denmark and had a very unusual start to life when he was abducted by his wealthy and childless uncle, raised in his castle and had his education paid for, being forced to study law. However, it was the stars which fascinated Brahe, and three key events changed the direction of his life. The first was the predicted eclipse of the Sun on the 21st of August 1560, which fascinated then 14-year-old Brahe. The second was his own observation of a conjunction, that means a close pass, between the planets Jupiter and Saturn. The third and probably most major event was when Brahe discovered a new star within the constellation of Cassiopeia. This made Brahe realise that the old records must be incorrect, so he set up an observatory in Denmark where, along with his students, he set about gathering observations and entirely rewriting the astronomical records which had existed. By collecting all of these observations, the most accurate possible without a telescope, Brahe and his assistants accurately recorded the details of 770 stars in our night sky. One of Brahe's students was Johannes Kepler, and before Brahe died, he left all of his work to Kepler, and you're about to hear what influence that had on the world. Johannes Kepler. Johannes Kepler was born in 1571 in Germany, and he was a mathematician and an astronomer. Kepler believed that Copernicus was right, that the Sun was at the centre of the solar system. However, he wanted to be able to explain the motion of the planets in the solar system as they appear from Earth. Kepler worked very closely with the astronomer Tycho Brahe and used the data Brahe had left him to calculate the movements of the planets in the solar system. From this work, he devised three laws of planetary motion, which include the fact that planets move in an elliptical shape rather than a circle as previously believed, and also that the speed that planets orbit around the Sun changes depending on their distance from the Sun. Kepler's three laws provided a mathematical explanation for the motion of the planets within our solar system and laid the groundwork for the field of celestial mechanics. The work that Kepler did also had a major impact on one of the most famous names in all of science, Sir Isaac Newton. Henrietta Swan Leavitt. Henrietta Swan Leavitt was born in 1868 in the United States and is one of the unsung heroes of astronomy. After studying astronomy, she suffered a severe illness resulting in the loss of her hearing. She later took up a position at the Harvard College Observatory, where she was tasked with analysing photographs of the night sky and recording the brightness of each of the stars. However, Leavitt noticed something odd in the photographs. Some of the stars had a variance in their brightness. Leavitt also observed a relationship between how bright a star is and how long it takes to complete a full cycle. This is known as a star's period luminosity, and other scientists have been able to use the period luminosity to calculate how far away a star is from the Earth, giving us a greater insight into the sheer scale of our universe. However, this would not have been possible without these astute observations from Henrietta Swan Leavitt. Edwin Hubble. Edwin Hubble was born in 1889 in the United States and is a great example of not needing to have your career figured out and set in stone. Hubble worked as a high school teacher and as a lawyer before becoming an astronomer. After serving in World War I, Hubble started working at the Mount Wilson Observatory at a time when people thought the Milky Way was all there was to our universe. One night, while observing a cluster of stars, Hubble noticed a variance, a giant star that was getting brighter and dimmer with time. Hubble built on the work of period luminosity by Henrietta Swan Leavitt and was able to calculate that the star he was observing was about 1,000,000 light years away. If a light is moving away from you, it starts to appear more red, and this is known as a red light shift. Hubble used what he knew about light speed and about the red light shift to determine that the further away from us a galaxy is, the faster it is moving. This provided the first recorded evidence that our universe is expanding and completely changed what we thought about our universe, given the fact at that time it was thought the Milky Way was all there was. But Hubble was able to observe things that were far beyond that. The Hubble Space Telescope, which has observed stars around 13 billion light years away, was named in honour of this amazing astronomer, Edwin Hubble. Annie Jump Cannon. Annie Jump Cannon was born in 1863 in the United States and is often known as the census taker of the sky. As a young girl, she would observe stars from her attic with her mother, and they would use books to identify the stars and constellations that they were looking at. Early in her adult years, Cannon developed scarlet fever, which resulted in the loss of the majority of her hearing. Cannon worked at the Harvard College Observatory with Henrietta Swan Leavitt, who was also deaf. Cannon's job was to observe and classify the stars. However, at this time there was some debate about how the stars should be classified, so she found a compromise and set up the Harvard classification system for stars based on surface temperature and arranged in a continuous series, and this is still the basis for stellar classification today. Cannon recorded and classified around 225,300 stars, discovered 300 variable stars and 5 novas. Cannon became the first woman to receive an honorary doctorate from the University of Oxford for her work on classifying the stars. Edmond Halley. Edmond Halley was born in 1656 in England, and he studied at Oxford University, where he became interested in astronomy. However, Halley then left university to travel in the South Pacific, and while there he documented the positions of 341 stars and recorded a transit of Mercury across the Sun. Halley realised that observing a similar transit by Venus would allow you to be able to calculate the distance between Earth and Venus and the Sun. Halley was also interested in problems of gravity following on from Kepler's 3 laws, so he travelled to Oxford to visit one of the most famous scientists in history, Sir Isaac Newton, only to discover that Newton had already solved the problems in gravity. Halley was so impressed with Newton's work that he helped fund Newton's landmark book, the Principia Mathematica. Halley's most famous discovery came in 1705 when he realised that observations of a comet seen in 1531, 1607 and 1682 were all very similar. Halley determined that these must all have been the same comet, which passes by Earth every 75 to 76 years, so he predicted when the comet would next be observable. Although he was not around to see it, Halley's prediction came true, and this comet is now known as Halley's Comet. It last passed by the Earth in 1986, and it will next pass by the Earth in 2061. Christiaan Huygens. Christiaan Huygens was born in 1629 in the Netherlands to a wealthy family, and he was fascinated by astronomy, even building his own telescope. Huygens discovered one of the moons of Saturn, known as Titan, and also discovered that the ears of Saturn, as they were described by the astronomer Galileo Galilei, were actually rings that encircled the planet. Huygens was a very talented scientist, so he didn't just make developments in astronomy, but in other areas as well. For example, Huygens developed a clock which used a pendulum, and this greatly improved the accuracy of clocks. At that time, a clock could go out by 15 minutes in a day, but with the Huygens clock with the pendulum, clocks stayed within an accuracy of 15 seconds. Huygens also theorised that light moves in waves through a substance called ether. This is how he explained the reflection and the refraction or bending of light. Though this theory wasn't entirely correct, it did establish the idea of light moving in waves. William and Caroline Herschel. I'm finishing up this list with a brother and sister duo. William Herschel was born in 1738 in Germany, and his sister Caroline was born 12 years later in 1750. Their father was an army musician, and William initially followed in his father's footsteps. When William moved to England, he tried to improve his social standing by becoming a music teacher, performer and a composer. In 1772, William brought his sister Caroline over to England, and they started their astronomical journey together. William realised to be able to see more of the night sky, he would need a telescope that used bigger mirrors to catch more of the light than were available at that time, so he decided he would have to make his own telescopes. In 1781, while observing the night sky, William noticed something which did not seem like an ordinary star. In fact, he had actually discovered the first new planet since ancient times, Uranus. This made William a star overnight, and he then shifted his attention to studying nebulae. Throughout most of his research, William had his sister Caroline by his side. While William was making the observations, Caroline was noting these down and summarising them. Together the pair observed and recorded 2,500 nebulae, and Caroline even presented evidence to the Royal Society of 560 stars which were not included in the British catalogue. William died in 1822, and in 1828 Caroline was awarded with the gold medal from the Royal Astronomical Society for her work in reorganising and adding to the British catalogue of stars. In 1835, Caroline Herschel and the Scottish astronomer and science writer Mary Somerville became the first two female members of the Royal Astronomical Society. Thank you for watching this video in the series 100 Scientists Who Influenced the World. The majority of the information for this video came from the books 100 Scientists Who Made History and the Britannica Guide to the 100 Most Influential Scientists. If you liked this video, please hit the like and subscribe buttons to stay up to date on all future content, and be sure to check out the other videos I make, such as the science demonstration and explanation videos, robotics and coding, and my STEM career interviews. This has been STEM with Mr. N's 100 Scientists Who Influenced the World, Amazing Astronomers.